Next concept is the complex representation of signals and system. Here in the complex representation, the envelope is used. The envelope is a pattern or a message which may contain all frequency components of the baseband signal. Generally here there is a three types of envelopes, that is a pre-envelope, complex envelope and natural envelope. Wherein the consider a pre-envelope here, the Hilbert, as we know that the Hilbert transform of a signal is defined for both positive frequencies as well as and negative frequency. The frequency content of a real valued signal g of t can be modified such that the negative components are eliminated using the complex valued signal called as a pre-envelope, where in the pre-envelope the negative frequency components are eliminated. Consider the pre-envelope of a real valued signal g of t can be defined in the complex valued function, that is g plus of t is equals to g of t plus j g cap of t. Call this as an equation 1, where we can tell as a g cap of t is nothing but an Hilbert transform of a g of t. Hilbert transform of a g of t imaginary part of the pre-envelope, because j is the imaginary part and g of t is the real part of the pre-envelope signal. Let g plus of t, that is denote the Fourier transformable of g plus of t only. G plus of f is a Fourier transformable of g plus of t. Then we can tell that by the representation we can write g plus of f is the Fourier transformable of g plus of t. G plus of f is equal, that is if we applied this to the Fourier transformable, the signal g plus of t, we can write it as an g of t plus j g cap of t, where g plus of f is equals to g of t, that is the Fourier transform of g of t is nothing but a g of f only, plus j small letter g cap of t changes to g cap or capital letter g cap of f, where we know that the concept, that is g plus g cap of f is equals to minus j sigma function of f into g of f. This concept we know in the Hilbert transform only. If we apply this to the above equation, that is g plus of f, that is where the complex pre-envelope complex can be representation that but the plus symbol, g plus of f is equals to g of f plus j, where that is this signal this value is this is applied to the above equation, g into g of f in plus g of f plus j into minus j sigma function of f into g of f, where g plus of f is equals to, we can take it as g of f plus minus j into plus j into minus j, will get the answer minus 1. Again minus 1 into minus 1 will get the answer 1. Therefore directly we are written as a sigma function of f into g of f. So g plus of f is equals to g of f, if we take common here, then remaining terms are 1 plus sigma function of f, where we know the concept of sigma function of f is equals to, f is greater than 0, the value will be 1, f is equals to 0, the value will be 0, f is less than 0, the value will be 1. If these conditions, if the these sigma conditions is applied to the above equations, that is in the pre-envelope, we'll get the g plus of f is equals to g of f, 1 it is there, 1 plus the sigma function here it is there, no, this we are applying here, we get the value is 1, therefore 1 plus 1 is 2, and g plus of f is equals to 2 into g of f. If the value sigma function is 0, the value g plus of f is equals to, where the frequency content f is 0, therefore g of 0 into 1 plus of 0 will get into 1 only, therefore g plus of f is equals to g of 0 only. If his frequency is less than 0, the value will be minus 1, where here if we apply g of f into, that is 1 minus 1, the value is 0 only. We know that is g plus of f is equals to 0. We can write these three conditions as in the in the value f is greater than 0, the value will be 2 into g of f. When f is equals to 0, the value will be g of 0 only. For f is less than 0, the value is 0 only. This in the written in the spectrum as a at 0 we have a that means at the positive frequency we have a signal like this, pre-envelope of g plus of t. And if we're in the frequency domain, the whatever the signal g f of f is there, no, this we get if we done inverse Fourier transform, we will get the small letter g plus of t. That is, we can be written as small letter g plus of t is equals to 2 into integral varies from 0 to infinity g of f into e to the power of j 2 pi f of t into dt. The above equation is for only positive frequency signal. And for the negative frequency signal, we can write it as a g minus of t is equals to g of t minus j g cap of t, where g plus and g minus of t are nothing but the complex conjugates of pre-envelope. That is, g minus of t is equals to, because the positive frequency we will get a g plus of t plus j g cap of t, where the negative frequency we will get the minus g j cap of t. Therefore it is a complex conjugate. Directly we can write as a g minus of t is equals to g plus of conjugate t. Directly by doing same was what we did like a positive frequency, for same negative frequency also if we done like this, means for the frequency f is greater than 0, the value will be 0. F is equals to 0, the value will be g of 0 only. If f is less than 0, the value will be 2 of g of f. This is the spectrum of a pre-envelope of a negative frequency. That is, it varies from minus omega to omega. The amplitude will be 2 into g of 0. And if we added signal, that is g plus of t and g minus of t added the signal, means we will get directly 2 into g of t only. That is g plus of t plus g minus of t. This is, if we get g plus of t plus g minus of t is equals to 2 into g of t.